Good morning, everyone. Today is the 12th of April 2020. Today, we are going to continue with lesson number 8.4, but it will be part number 2. In the previous week, we had started with 8.4, but it was part number 1. Okay, now let us, as usual, go through the agenda that we are going to follow for today's lesson. As a starter, I will ask you 4 questions, and these questions will pop up as usual in order to recap some ideas of lesson 8.4. Then we are going to discuss very important topic, and this topic will not need any calculation as the previous lesson. It will all be theoretical part. Number 3, you are going to solve a task using Google Form. And number 4, we are going to solve a plenary using the Mastery Connect. The objective of today's lesson is to explain the difference between intra and intermolecular forces, and then we are going to discuss a little bit more about 2 types of intermolecular forces. These 2 types are called van der Waals forces. In today's lesson, you are going to hear many key terms, and all of them, no, not all of them, but most of them are new for you. One of them is intramolecular force, the other one is intermolecular force. Also, van der Waals forces. You will hear also from me the word dispersion force and also dipole force. Okay, so let us start. As a starter, I want you please to answer these 4 questions, and please try your best not to have any spelling mistakes, because from the previous videos, I saw many of you did spelling mistakes, and so the answer will be considered incorrect. So try your best please to spell the words correctly. Question number 1. Diatomic molecules such as F2, I2, H2, and O2 are they polar or not, according to the previous lesson? Because the electrons are pulled equally or not, and these are identical atoms. Number 2. The higher or lower the difference in electronegativity will make the type of the bond less or more polar. Number 3, if the difference in electronegativity between atoms is 0, please remember the ranges, the electronegativity ranges. So if the electronegativity between atoms is 0, so the type of bond is it covalently polar, non-polar, or ionic? If the difference in electronegativity is greater than 2, so what could be the type of bond? Again, is it covalently polar, non-polar, or ionic? Okay, now after you solve the main ideas, after we recap the main ideas of the lesson, what we need to learn today that in chemistry, forces can be classified into 2 types. One of them is called intramolecular forces, and the other one, the other class, is called intermolecular forces. In this slide, I want briefly to talk about the differences between intra and intermolecular forces. First, when I say intramolecular forces, it means that this force can be formed between atoms. It means that this force is within a molecule between the atoms. If I have H2O, the bond between the H and the O, this bond is called intramolecular force because it is between the H and the O. And these 2 are atoms, and these 2 are within a molecule. But when I say intermolecular forces, this force, it is not between atoms, it is actually between molecules. So if I have a molecule of water, H2O, and another molecule of water, which is H2O, and I bond between them, then the bond between these 2 molecules will be called intermolecular forces. And when I say intermolecular force, it should not be only between identical molecules. It could be between a water molecule, H2O, with CH4, with a methane gas. So it should not be identical, but it should be between a molecule and another. Now, another is the second difference between them. When I say intramolecular forces, which is between atoms, this force will be stronger than the force which is between the molecules. Because here we are talking about a force within a molecule. So atoms are closer to each other and they are small and they are attracted more to each other. So the force is stronger. But when I say forces between molecules, so molecules might be different, might be not, the size will also affect. So when the bond is between molecules, so this will be like a weaker relationship between these molecules, so we will have a weaker force. And having stronger and weaker force, it will show us also difference in properties and difference in boiling point, difference in melting point, and also in freezing point. Okay, now intramolecular forces, actually these are things that you have studied earlier, but you did not know that we classify them as intramolecular forces. One of them is the covalent bond, the one that we are studying from the beginning. The other one is the ionic bond, this one you took it in grade 10. And the metallic bond also, you study it in grade 10. But for intermolecular forces, these three are new. Today, we are going to learn the first two, the dispersion force and the dipole-dipole force, and we will leave the hydrogen bond to the next session with solving some other equations. And by the way, I arranged them from the weakest to the strongest. So dispersion force, dipole-dipole force, and hydrogen bond, these are intermolecular forces and they have differences, and also they are some of them is weaker than the other. The dispersion is the weakest, dipole-dipole is stronger than the dispersion, but the dipole-dipole is weaker than the hydrogen bond. Okay, let us go further. Now, the intermolecular attractions are weaker than the ionic or covalent bond, because as what we said earlier, that intermolecular forces are weaker than all the intramolecular forces. Okay, now another thing, as I said earlier, the differences in strength will always tell us different properties, and because we will have different properties and different physical properties, actually, these different properties will give us different state of matter. It will give us a gas, liquid, or solid, and also we will talk about this in details. Okay. As I said, for today, we are going to start with the first two intermolecular forces, the dispersion force and the dipole-dipole force. Now, these two are considered intermolecular forces, and they classified both of them as van der Waals forces. They put these two together in one batch, let me say, and these two are called van der Waals forces according to the named after the chemist Johannes van der Waals. Okay, and these two are, as I said, weaker than the hydrogen bond. Let us understand what is dispersion force and how it forms, and let us understand what is dipole-dipole force and also how it forms. First, the dispersion force is the weakest among all the intermolecular forces, and it is actually it forms only because of the motion of electrons. In this slide, I will explain for you what is dispersion force in general. In next slides, I give you exact examples where we see dispersion force in chemistry. On the left side here, on the left-hand side here, you will find two circles. One of them is called A, the other one is called B. Here they are trying to represent for you how the dispersion force is formed. I want you to look at A. Imagine that A is an atom and B is another atom. Now, we know that electrons are always moving. Okay? Now, for a second or less than a second, if the electrons are moving, let me say clockwise, for a second or for a while, these electrons will be in one side more than the other side of that atom. So, for a less than a second, as I said, electrons will be, for atom A, electrons will be on the right side. At the same time, electrons for B will be also on the right side. So, if I want to represent this using the partial charge, the delta, it will form this type. If, for example, this one.